Welcome to our second day here. Thank you for being here at this workshop. My name is Lina Bosaz. I am the person in charge today of the moderator. I am coordinating this service crops workshop within Aapresid, and we're going to share the results of the service crops for something we have been speaking about for many years. We're going to talk about grazing within this system, the demands that we want to respond to, consultations and through talks with producers is based on sustainable technologies and ways to intensify production systems. And we always base ourselves on wanting to have a systemic view on the approach to problems under these two mottos. And for those who were yesterday at the workshop for agricultural systems, this is one of the 10 projects we have in our program, and it is based on 3 pillars. The first one is production, the producers who bring us the places where we can run our tests, then the experts who analyze the information and disseminate it, and then we also have companies that bring resources forth for testing technologies and knowledge, trying to I'm going to present here Alice Tomassetti, who is part of the coordination team. He teaches animal production systems in the National Rosario University. He's part of the technical coordination of the network, and he is doing a master on conservation on natural resources with grazing and also service crops. And Clara Aranguren, who is an agricultural engineer from the University of Buenos Aires, and she's part of an integrated system project. And what it wants to do is to integrate the systems in a sustainable way so that these service crops can be used for grazing, and to give some protocols to work to help for this grazing, and this way to handle service crops can be as efficient as possible, and to have reports that show results from different areas of the country and different ways to manage the land. So, Clara?
Bueno, buen día a todos, ¿cómo están?
Good morning, everybody. Before we begin with the results that Alex will present, the idea was to talk about why, from integrated production systems, we began in the service crop grazing network. We always do a workshop for creation where we determine which lines will be followed. And when we did this workshop, there were a lot of issues with regards to grazing, which are these 3 questions that producers were asking. The first one was, this allows us to produce grain and meat. Does this compete with agriculture, the service crops and grazing, right? The second was, what benefits or what problems does the incorporation of service crop bring, and how can we maximize meat production on service crops? And from there, we have producers, one who is convinced that grazing service crops is the right path, and then the network also talks about how to do it better, how can we maximize meat production. And then there's the other producer who's not so sure about using meat or knowing the advantages and disadvantages of this grazing. The idea is to present the systems and to explain how the grazing service crops helps for cattle raising. This is the 2N system. It is in blue. In the image, you can see two maps. The first one is the use of soil in autumn and winter, and on the right, how it changes in spring and summer. What you see in orange, this is 23-24, used for agriculture, and in green, what was used for cattle raising. You can clearly see that the surface for cattle raising in autumn-winter was much higher, and this is due to service crops. So when we evaluate what was the proportion of all of the foraging systems, we can see that the system is based principally on service crops. What is the effect of this on our systems? It allows us to have a load of 57 times higher in winter than in summer and spring. So the system does the service crops and uses the corrals when we have to go to agriculture. The corral is the fuse to be able to do this. And on the other hand, we have Santa Elena, where we have service crops that have a lot of importance, but from the other side. When we see the proportion of this with the perennial grazing, we see that we use prairies a lot here. And if we look at the map again, when we see the use of soil in autumn and winter, we see that it is represented more by service crops. And when we see what happens with cattle, we can see that cattle, when we value the load, we can see that this allows us to diminish the load in autumn and winter. So the importance of service crops would be in being able to keep the cattle in autumn, winter, and spring, summer. Okay. Thank you, Clara. Thank you, Lina. And I also wanted to thank part of the general coordination of the Aapresid as well, who is part of the network. And Julio Gali is missing here. And they are part of the technical coordination. This is the 5th year of the network, and Julio wasn't able to be here, but we were working jointly with the data that we can see here today. And we'll see if we can actually respond to what Clara was speaking about. First, we're going to speak about the different ways or the different scale of integration. When we go to a farm and we see the differences and the interactions between the diversity and the use of soil, and not just the use of soil, but also activities. For example, in one farm, you can have different activities, different subsystems, because we can have cattle, raising, agriculture. You can have them on different lots of, and that will be part of the breeding and the wintering, and in others we may have pastures. And as a farm, we can see an integration when we go and we do a scale lot-wise. When we talk about integration plot-wise, we begin with rotation that can take into account crops. We can have a rotation with service crops, It's still agricultural rotation, and we can also integrate these service crops, and then we can use the soil in a way as a system. And we can think of this plot-wise. We can use grazing. We can make the decision of whether to graze or not to graze on that particular plot. When we speak about integrated systems, we do have something that is key, and it has a certain dynamic or complexity, which has to do with planning. Planning is crucial to be able to, when we want to, for example, rebreed, and we put them on the plot, we have to plan short, mid, and long term in order to allow us not to have a place without grass, and we need a long-term tool for rotation, because we know that a certain amount of plots in my system will have to have forage that will have to be set up so that the cattle can go through the different lots without missing out on food. And then we have the foraging balance and the receptivity, and we will be able to know what load we'll be able to handle, and in foraging, the distribution of foraging, so that we don't have gaps without food. This is a summary of the incorporation of service crops, thinking about this as a rotation where I want to incorporate the different service crops in order to graze. When the systems began with service crops, we began to see rotations in grasses, perhaps in soy, thinking about controlling weeds and generating structure and improving the soil. And then we would see that it worked, and we had rotations that would go from grass to grass before maize or corn. And then we thought that maybe we could put different species together. We could incorporate nitrogen with different types of plants. And then we could see that we can use rotations to intensify the use of the soil, so that through these we can think what services you need for my lot, what I need for my rotation, for my lot, and begin to plan that. In the agricultural systems, what we need is to think today and to plan the times for sowing, so that we can have expanded crops, and taking into account when I'm going to dry this service crop, because what I need to do is to look after that period of time, so I store water so I don't compromise the next crop. So it's still a bit complex, but we will do a service crop thinking about when to dry it to be able to accumulate water for the next season. This Pinto and Fernandez did this study in 2017, and they said that monocrops occupied 89% of the land in Rio de la Plata, and there was a proposal to do crops to raise the ecosystemic services. And look at the map. You have the core area. The points that you can see don't take into account those points, but only what is colored. Everything that is blue are areas that were determined as service crops that could be 4 or 5 months without changes in the water in the soil. Everything in red is service crops that could only be there for 3 months, and this was due to less rains during these times. But if we can plan this, if everything works our way to be able to sow service crops, they produce, we dry them, etc., and we manage to be on time, that's great. But for this system, what happens when, through the integration with cattle raising, we have animals that are grazing on the service crops? Then what we have a problem with decision-making. Because what day should I dry this service crop to begin to store water in my fallow for the next season? If I have a circuit with the foraging that I planned before, if I have to sell, if I have to keep it there, whether the price is right in that subsystem where there are other variables at play that I cannot decide upon. So the question I ask myself is, how do I pasture, how do I do this grazing so that we don't break up the system, so that we can cover the need of my plot, and on the other hand, I have cattle activity and it's responding. And that's the question that we want to talk about once again. And in order to do that, we have this network. As Marina was explaining, we have 4 years of closed campaigns, and we are in the 5th year now, where the network will have experimental sites, coordination. The experimental sites do this protocol that I'm going to explain now, and then we do the reports that producers and partners can see through our annual reports. What does it do? The protocol that we set up has as a common factor or a common denominator among all of the producers the fact that grazing needs to be moderate, and we mean that we need to leave a remnant of 15 or 20 centimeters. And what we do is we designed a grazometer. It is an acrylic disc. This is just a piece of stick with numbers on it, and it allows us to walk through the service crop to measure height. So we put the disc down, and when this touches the first leaf, and we see it from the top because it is transparent, we know the height. And what we did was to design 3 different treatments, one with chemical fallow, one with service crop not for grazing, and the one in green, which is a grazing service crop. So on these 3, we will compare different variables. And there is a repetition so that all of that information can be statistically analyzed. And these are the variables we are measuring: height, biomass, production. We also do weeds, the yield of the following crop, and sometimes other measurements to see what happens with the fact that the animals are stepping on the soil. We'll take this map once again to show you where these sites are on our network. We have some that are incorporated within the south, some are, within the blue area, some in the red, and some outside of them. And what we do see in these sites is the following, that each producer makes decisions according to what their plot needs, what service crops they need, and we begin to see that there are producers that do pure rye, oat, triticale, and some that do multi-species, so they do oat and vicia, the 2 different types. They do rye, they do red oats, and all kinds of different plants. We could not just use the fallow that we wanted to use. And we were saying we need so many days to be able to get the water for the agricultural, the variability that we have between the duration, between the drying of the service crop and the sowing of the next crop goes from 2 to 83 days. And in the middle, there is quite a bit. There are some producers who dried and then sowed the next day, and some of them had enough time to be able to store water. And what happened with water throughout these 4 campaigns? We measure water in the 50 centimeters of depth. And when we see the useful water per treatment analyzed every year on all the sites, we see that we don't have significant differences when it comes to availability, quantity of water when we when we sow the service crop. And we go between 60 and 50 millimeters average. And what strengthens this information, this variability?
Prácticamente el abecedario.
We have the ABC in terms of the significant difference that we see. Here we have millimeters, campaigns, 2021, 22, 22, 23, 23, 24. We have a different color for each campaign. So what we can see here is that in the first year there were negative values. The reason is there is a model. We measure useful water. We start with gravity metrics, soil textures, and hydric water constants, and some years we had negative values, and this is part of the variability. We do not have any difference between treatments because we have analyzed this comparing the different campaigns and the different sites. Not all years had similar rainfall patterns. So how about the succession crop throughout the years? For maize, we have an average for the 4 years. It is approximately 80 quintiles per hectare with a variation with data from 144 to 74 quintiles without significant differences throughout the years and campaigns and the sites. And the same for soy, 34 per hectare, with a difference between, or a variation, a range of 42 to 23. When we look at this from the campaign perspective, there were some differences as would be expected, and also there were differences across sites because we had a diversity of environments, and the same applies to soy. The different campaigns had different characteristics, showing significant differences, also differences across sites. But when we analyze treatment, analyzing the information per treatment, we do not find significant differences in that case. You can also see in the annual reports the same data. When we do the campaign analysis, we conduct a site-by-site analysis as well. So it is available for consultation, and you can have a year-by-year perspective. We take the view of agricultural systemic approaches, and we are considering grazing, but we also need to look at the productive side of cattle raising as part of this integration. Well, you can see the bars. The blue bars is the production or productivity per hectare that we are having in all sites and campaigns, and the bars in yellow, or yellow bars, illustrate the variation of kilograms per day. So this is a range. The minimum productivity or the minimum value is shown here. There is also an illustration of the value. Here, you also have the distinction of cattle raising that is fed with supplements. The values are just for grazing. The animal load in the different systems, well, the average is 5 head per hectare, ranging from 3 to 8. Some establishments have more concentrated groups. Those animals have a higher load and stay for fewer days because when they reach a certain level, they have to get out of the grazing paddock. Well, and there are other cases where animals stay for longer. 70 days is the average. But in some cases, they only stay for 21. In other cases, they stay 100 days per paddock. This is regardless of the grazing system. We are interested in the criterion of 15-20 centimeters. We continue having the benefits of the service crops, regardless of whether grazing is on the plot or continuous. This means that the producer that does rotation should be there every day. Those that are doing continuous grazing have to see that the animals are consistently distributed throughout the lot, so as to avoid double profiles. In this system, we can add some benefits or services. So these benefits are connected with grazing, and they have not been taken into account. We have the environmental animal load, and this illustration serves to exemplify that here, before the animals graze, we have plants that have soil nutrients. As cattle feeds, and also because of the different processes and the excretions, well, the nutrients change. To have an optimal animal load, we need some balance so that the crops are eaten at a certain rate, because we need to have the agricultural and systemic services functioning. We will have to prevent the lixiviation of nitrate lixiviation. We will also have some impacts. We will have better quality and less emissions. I would also like to show you something else. This is a study that was carried out over 10 years in one of the sites. And this is what was measured, the percentage of organic carbon in different treatments. Soybean, cover crops without grazing. The 4 treatments include soybean rotation with grazing with different intensity, and finally, pure soybean. After 10 years, we see differences in the organic carbon in the soil between pure crops and the plots that had cover crops with or without grazing. So Through grazing, we continue including some agricultural system benefits or services. Finally, I would like to show a study of 2018 by Shun. It focuses on grazing and how it affects the microbiome and the impact that the microbiome has on the organic carbon of the soil and on productivity. What we see is that between light and moderate grazing, we find the storage of carbon. We had looked at cover crops, but we also need to think about the services that can be added through grazing. We can focus on economic drivers. This is a historical picture. I'm not talking about the current situation. These are historical values taking into account the exchange rate of the dollar at 1.94. These are the percentages for each component regarding the cover crop cost and how it can be paid with indifference kilograms. We have fertilizers more than 30% in the nitrogen cover crop. And then we also have a cover crop without nitrogen with 160 kilos of beef we pay for the service, and with 109 we pay for the one that did not have nitrogen. So the average was 293 kilograms per hectare in production, with a range of 420 to 150. So the questions that we have is, will the service or cover crop always be feasible with or without grazing? So what is the case, or what happens with the useful water for the successor crop? What is the yield of the successor crop or the cash crop that comes after the cover crop? And what are the agroecosystemic services of cover crops and of grazing? And what is the profitability of doing both cover crops and grazing? Always we need 15 to 20 centimeters. That is something we need to remember. Thank you. You can send questions using the QR code on the screen. I would like to talk about the cover crop in the agricultural field, not in the integrated or mixed field. We have variability depending on the species used as cover crops. There is no single protocol establishing that a producer in a certain area has to use a certain species. We need to share protocols that have the fundamentals of grazing. Some questions. When we integrate systems or when we have agriculture and cattle raising at the same time, what are the considerations to make it successful? We talked about the remainder, but what are the trade-offs between cattle raising and agriculture? And what are the considerations that have to be made in an integrated system? When we talk about an integrated system or mixed system, we cannot compromise agriculture or farming and cattle raising. So when we take the animals out of the plot, we need to have the right planning to sow the cover crop at the right time, so as to achieve production that enables us to go into the field early, and it allows us to exit at the right point without compromising beef production and without compromising the cover crop. When you are late in terms of sowing, because there was no rainfall, for instance, we have shown extreme drought conditions in the campaigns. So sometimes there is late sowing, and the grazing also occurs late. However, we were able to cope with this situation. The idea is to have the right planning, to have the right timing for sowing, and the grazing should consider the remaining. As regards the production of biomass, we have questions regarding compacting and the structure problems regarding load. So how can you manage the biomass kilos to define the right time to go into the field? Or how can you preserve the soil structure? I was saying that we were looking at a penetration metric. We showed this in the previous Congress. Now we have more experience because it was a solution that had just been released. Now we have more experience. We have a lower load with approximately 3 head per hectare, and there has been rainfall of 40 or 50 millimeters, and the animals stayed in the paddock. And when we talk about the cover crop, it was the one that showed less compacting. Our hypothesis was that there would be no compacting in the cover crops without grazing. There could be some difference in the cover crops with grazing, but the fallow would be more compromised because of the lack of root strengthening. But in fact, this has been checked, and we have seen a difference between fallow and service crops or cover crops, but it is more noticeable in 5 centimeters and below. Non-grazing cover crops look a bit better, but in the centimeters where we see compacting, which does not restrict, in fact, the growth in the roots, the depth can be managed with no-till farming. That compacting that can be exercised with trampling, we are breaking that compacting with no-till farming. So we take care that no plants are uprooted. We take care that the rooting is, or the roots are appropriate. We consider this. And I attended Germán Beroni's presentation yesterday. They were talking about pastures, alfalfa particularly, and they were saying that they would wait for a certain height to be reached before the cattle went in. Sometimes when we reach that height, it is important to start grazing. Otherwise, we lose the timing. If we have more leaves, we have a higher growth rate, and then the timing is not right, and the grazing will not be balanced. That is why we need to be on top of cover crops and grazing. We need to ensure grazing is consistent and continuous. So we wait, and when the leaves start to grow, the growth steps up considerably, and we need to manage it. As regards grain crops, fertilization, in the network, we do not establish any fertilization protocol or dosage. The producer uses their own criteria, and this also considers the variability of the different sites. Can you please talk about the species that are used in the establishments and how we are interconnected?
Tenemos
In Buenos Aires, we have 2 sites, and both of them use oat as a service crop. What was the other question? Where they were? That's it. Where are they? Are they in Buenos Aires, and where? We have 2 more in La Pampa, which was incorporated for the campaign 25-26 for analysis, and another one in Azul, and the last one, because we don't have enough time. What happened with the grazing of Vicia? With regards to Vicia, we've always seen it in association with other plants, and so far, they have not had problems when it's used. What we also say when the goal is to have service crops, or what service we need, what we have in these associations is that if you do vicia with a grass, the grass begins, and then the vicia takes a bit longer to have rapid growth. And so we are making the most of grasses, and when the legumes come up, then we are almost closing grazing. So we don't get a great incidence of vicia in the grazing part. And on one hand, it's good to think about it from the point of view that this is a service for the grasses, and then when nitrogen fixation takes over is when we're closing the grazing stage. So that's where most of the fixation happens for the next crop to be sowed. Thank you very much, both of you, for your presentation. You can go to the Aapresid website so you can see all of the campaign more in detail, year on year. Thank you so much for having been here today.